All right, so I'm going to talk to you guys about some basic testing stuff using Nose and Pytest, which are the two best testing frameworks for Python. You have unittest, which is in the standard library. Probably if you've tried to do any testing, you've encountered unittest. If you use other languages, you've seen, XUnit, if it's JUnit or, InUnit or whatever. So you'd recognize unit tests, but Nose and Pytest are Pythonic testing tools. And if you're here, hopefully you think that the Pythonic way of doing things is a better way of doing things. And Nose and Pytest are more like that, so you'll probably like them. I do. And we'll talk about writing and running those Pythonic tests, and then using plugins to solve some real-world problems. So a lot of the examples are like testing code design. So you'll find, as you kind of write more tests, that if a thing is hard to test, it's probably because that thing is not well written. There's some places where that falls down, but generally, easy to test code is good decoupled code. So as you find, man, this is hard to test, that gives you the idea, hey, maybe I can change this interface to be easier to test, which results in less brittle code. And if you have complex design, so things that are not trivial, those tests will actually get you to a quicker implementation. So you're writing more code, and you have tests to prove things are working, and you actually get faster. You get to the implemented working code more quickly, which sounds like a kind of a free lunch, but it kind of is. And there are some caveats to that, but generally, if you're writing complex code, those tests help you get to what you want faster, not slower. It's not, man, I have to write all this code, so I can't get this done. It's, if I don't get to write tests, this is not going to get done. And then you have refactoring. You have all these benefits that you'll hear about more today. So good tools matter because you're going to write a lot of tests, right? So you're spending a lot of time in your testing tools. So those tools matter. Luckily, we have tools in Python that eliminate boilerplate and help you write maintainable tests because your tests are code. So you should not just think of what is the simplest thing I can do to test this code. You're going to have to, those tests are going to live with you. You should think about those the same way you think about your normal code. So all the tricks for, don't repeat yourself, good decoupling, those also apply to your tests. So as far as the write tool, this is our simplest test thing. We have a function to add one. It takes in your input and adds one to it. So this is a thing. I probably wouldn't write a whole lot of tests on this, but bear with me. We'll have harder examples later. So the Zen of Python. So two of my favorites are simple is better than complex, and flat is better than nested. Yay. Right. Everyone should be happy about that. So then we have the unit test module. And this is not horrible. This is better than not any tests, but we've got like this weird if name equals main, unit test main. I don't know why that's there. Like I just want to write some tests. I mean, shouldn't it be able to figure out that it's got test in the name? It's a unit test case. We can do better than this with Python. This is not horrible. This is better than no tests. If you have this, you should not feel bad about it. But we can do a little bit better. And we also have something. We're testing our add one. We're testing the -1 case because maybe we break. When you're testing, you should think in boundary conditions. So the things where things change. So changing around 0 is usually a common one. Changing around like really big numbers, that's another common one. So we are asserting that when we add 1 to -1, we get 0. So not too bad, but we can do better. That's very Java-y. If you showed that to a Java programmer, they'd be like, yeah, if name equals main, class main foo. It works. But we have Nose and Pytest, so we can do this more Pythonically. So this is what the minimal test case would look like in Nose or Pytest. Or py.test. I don't know. Does anyone know how to say Pytest? I think it's just Pytest. Okay. I'll say Pytest. That's what I've been saying. So you just have to write a function that has test in it. And then Nose and Pytest are smart enough to be like, man, that looks like a test. If it's in a test module, if it's a test function, it goes and finds it. And it pretty much does the things that you would do naturally whenever you're organizing your tests. It finds them and runs them, gives you output. So this is the same test, less boilerplate. Get out of the way. You don't have to remember what are the unit test semantics. You just say, test something, throw some asserts in there. Everyone knows how to use asserts. It has some, nose and Pytest have some assert helpers, but this is the simplest test. Now, when we get more complex, we have things called test fixtures. So if you've never used a test fixture, it's this concept of I got to do stuff before my test to create conditions that are testable. So if I have to load data for a database, maybe I have to do things for a file system. These are things you need to do to put your system in a state where you can then test a change. So we have fixtures and cleanups. And then we have things like, what if I'm trying to test something that writes the standard out, and I want to test what is on the standard out, I mean, you guys, it's just Python. You could write stuff to redirect standard out and save it to a file and do all that, but that takes time, and Python is a high-powered language. We want tools to do the things that we do often, and testing standard out, it happens often. So luckily, Pytest gives us good tools for that, and I'll show you those. And it has really good tools for file system tests. So if you've ever had to test something on a file system, you have to think, well, what happens if my test fails? Am I leaving around temporary files that I have to worry so subsequent test runs hit those files? And you can write Python code to clean up your directory and make temporary directory and context managers, but Pytest just gives us cool stuff. And there's lots of other cool stuff it gives us, but these are some common ones. So an easy file system test, so this is something, this might, standard out in file systems, I think, are the things that you encounter first when writing tests that break between test runs. So Pytest has this really cool kind of dependency injection, which is a fancy way of saying it just gives us what we need. Well, it's not really, but it gives us what we need when we start the test. So if you see this, this tempter argument, this is kind of a magic thing that Pytest gives us. If you write a test function and an argument is tempter, it creates a temporary file system and passes that for you and then cleans it up for you. So I didn't have to write any code, and I got a free temporary directory with cleanup that I can do stuff with and reliably test. So that's pretty cool, because we need reliable tests, because tests that sometimes pass and sometimes fail that you can't trust are not a lot better than no tests, because then you start ignoring the tests, which I've done. Who has written tests that become brittle, and then they forget about them, and then later on they would have caught a bug that they didn't. Anybody? It's happened to us several times. Test suites, they age, and if you don't take care of them. So this is a way to stamp out those brittle tests. So I'm going to give you a little history lesson, because you're thinking, well, if nose and Pytest are both really good, why do we have both of them? Kind of historical reasons. In the beginning, we had unittest as part of the standard library. It's maybe not so good. One of the things that just bugs me is it has camel case method names. I don't know if you guys have noticed that, but man, every time, flake8, all the things, I don't like it. But unittest is better than no test, so write tests. But along came Pytest. So this was really the first simple Pythonic, I don't know if it was the first, but it was the first major simple Pythonic testing tool. And it made discovering tests easy, so you didn't have to do unit test things. You could just write test modules. But there were some problems. It was a little tough to install. I don't know if you guys remember the mid-2000s Python world, but installing things was not like now. You couldn't just pip install and everything mostly worked. So Nose came along, basically a fork of Pytest. It worked with unit test for free and gave you better plugin systems, so people switched to Nose, and then Pytest caught up. There have been about feature parity since 2009, so now you could pick either one. I think now, I use mostly Nose, but I think if I was starting a new project, Pytest has better documentation. They have some really cool parameterized fixtures, and they both have a really good plugin ecosystem. So if you're just starting out, I think I have to recommend Pytest. But if you like Nose, you know Nose, keep with Nose. There's Nose 2, which I'll talk about a little bit, I think, at the end. But they're both really good tools, and you won't really notice a big difference. So how do we get started? So we're going to use a virtual env. If you don't know what a virtual env is, I recommend the Hitchhiker's Guide to Python, where it will give you a really quick overview of what that is. But it's basically a self-contained Python environment where I can install stuff. You should be using virtual env for everything, or a tool that wraps virtual env, something to isolate your requirements, because it's 2015 and we have cool tools to do that. Because if you remember the days when you didn't, And pip is how you install all the things. So pip install nose nose space Pytest will install both of them for you so you can play around. So you should use these, again, because they have better test discovery and running. None of that if name equals main, unit test, main stuff. You just run. None of this. This is goofy. So nose and Pytest run everything. So anything, if you have a unit test case that you've already written, it'll just find it and it'll run it. If you have a test foo module, so test foo.py, it'll find it and run it. If you have a test function in a module, it'll find it and run it. It'll run doctest, which I'll talk about in a little bit. So these are some of the options you can do. So you can give it, there's a lot of different ways to pass arguments to nose tests and to Pytest. You can give it the py.py file. So if you have like command line autocompletion, that's usually the easiest one to start with. You can also give like a dot separated module path. You can give, like if you use a colon to represent a module, you can actually get into a module and call a specific method on a class. You can do a fat path to a file all the way to a function. So all of the ways you could possibly think to reference a test you can do with nose. And there's also some, and Pytest. And there are some good plugins if you Google around for autocompletion with the modules, which if you have a big test suite is super valuable. So you can just tab complete, test dot tab complete, and get all the way down to your tests. And you can also just, if you're in a package, you just run nose test or py.test. It'll just go and do a default same thing and look for Python modules, find the tests. Really easy. So it also runs doc tests. With nose, you have to give a with doc test argument. Pytest does it by default, I'm pretty sure. If anyone can correct me on that. So a doc test, if you've never seen these are, I have a love-hate relationship with doc tests. Mostly hate, yeah. I think they're really good for testing documentation, which is valuable because you want your documentation to not have typos. And they're often the easiest test to write. So if you see that, it looks just like an IPython, like an interactive, or just an interactive Python session. You have those little 3 sideways arrow things, what you would type at the command line and the output. And this will actually verify that exact output happens. So this is like the easiest way to start testing. So if you've got no test, maybe write a doc test. I would rather write this as test add -1 as a function and keep it outside just because it's easier to reference and I think maintain. But doc tests are not evil. They're better than no tests. So there are other test types. You have a class. So this looks like our unit test module if you guys remember this unit test example. But we don't have to import unit tests. We just say, hey, we have a class that ends in test. This is clearly a test class. Thanks, nose and Pytest for running this thing for me. I don't have to remember the API. I can just write methods that have test in the name, and it does the right thing. And I'm just using bare assert, but there are lots of assertion helpers. So you have, and then you can do assert equal, and it will give you a nice output about what was not equal. You can assert not equal. You can assert true. You can assert there are a lot of test helpers. So basically anything you want to compare, there's a helper for it. You should check the docs before you write your own. Another cool test type with this that you cannot do in unit test is a generator test. So who knows what generators are in Python? So most of us do, some of us maybe don't. So generators are things, if you see a yield statement, you're probably in a generator. That's kind of a good bet, but it's kind of an iteratable that is created incrementally. For our purposes, what it means is I can use a test function to create other test functions. So it's a function that creates other test functions, which is really cool. It makes it easy to do data-driven tests, where you can just create a bunch of lists of different types of data inputs and the outputs, and then you can pass those along. So in this case, this test evens function is iterating from 0 to 5, and for each one of those combinations, it's yielding another test. So how many tests do you guys think I will have at the end of this run? 6, 5, depending on you're off by 1. I don't actually remember. Something like that. Yeah. So you will have actually 6 or 5, one of those two numbers of tests. I would just run it and see what happens. And it will run with each combination of those numbers. So it's yielding the function and then the inputs. And it'll run each one of those, and you'll get a different pass-failed for each combination of inputs. So we also have different setup and teardown. So this is the setup and teardown were for fixtures. Remember, we need to create our testable, non-brittle environment. And we have lots of tools with nose and Pytest to do that. So we can do that at the module level, at the class level, and at the function level. I do a lot of this at the class level, but this is where you have a setup function, and that setup function runs before every test. So before test -1 runs, that setup function runs. So if we, I don't know, inject something, add one to change the behavior or change what integers do, I don't know what we could do in this case, but we do setup here, and that would run every time before the test runs. And if we had a teardown function, that would run after that test runs. And we can do this at a higher level, so we could write a setup and teardown function at a module level, and if we had a bunch of test functions, those could also run before and after every test function, which is pretty powerful. You can't do that in unit test because everything in unit test has to be a class. So having the module level setup and teardown is pretty great. You can also do them on functions, which ends up looking kind of weird. There's some decorator syntax, but you can check the docs for that. It's definitely possible. I'm going to talk a little bit about configuration. So both nose and Pytest have lots of configuration options. You can throw files in like different places on your home directory and your project path and say, I want these plugins. I don't want this behavior. I want to default to verbose. I want to pass these arguments in. So these are just tools to not have to do command line arguments all over the place. So in the case of nose, got to set up CFG, nose RC, nose.cfg. We could put it wherever we want and change behavior, and it's just an INI configuration. Lots of good options there. If you find yourself typing things out at the command line, put it in your nose RC or your nose config, because you should be running tests a lot, and typing every time you run tests kind of sucks. Another pattern you'll often see is projects will have like a run tests script that if you have like, I want to run multiprocess, and if I run multiprocess, I have to switch my database. That's something that you can put in a run test script that'll kind of minimize the typing. So I definitely recommend that pattern. Pytest reads pytest.ini, tox.ini, or setup.cfg. So tox, I'm going to talk a little bit about later, but tox is another tool to help you run multiple versions of Python with different configurations, maybe different requirements. It's great, especially if you're maintaining a library. It has to be compatible with different versions of things, which if you're open sourcing your stuff, you should. And at least you'll probably contribute to a project that uses tox. So it's nice that Pytest just works with tox. So I'm going to talk about this is a more advanced Pytest feature. So this is this fixture injection concept. So this nose doesn't have this. This is maybe my favorite thing about Pytest. I'm definitely more of a nose expert, but this is really cool. I wish nose did this. So this example is complex. We're going to spend a little time on this. So we have some complex data that is going to change, maybe. So think in this complex data, we're setting up lots of test data. Maybe we're creating users and users need profiles and doing lots of complicated things. Maybe we could be spinning up web servers. We could be doing a full text index. There's lots of complex things we could do in this complex data setup function. And one way to do that is just do it all in the test and then not be able to reuse it. And then we really have a situation where we need tests for our tests. But what Pytest lets us do is injects that complex data fixture into our test, which is easy, and then do things with it. So our complex data has a string property on the object and a list property on the object, basically. And we're just testing those properties. So those are being injected into our tests, and we can use them in the test, which is pretty powerful technique. If you've used Angular's test harness stuff, you've seen some dependency injection, things like this, and it really helps you keep your code focused on testing one thing, and you don't have to test your entire system just to test one part of your system, which is a very powerful technique as your systems grow. So in this case, we're testing, hey, is this thing the string? And where string is defined as whatever we said it was in this test fixture. Is this thing a list? Where a list is defined whatever we said it was in this complex data test fixture. So hopefully that makes a little sense. I'll show you why I really like this pattern. Because if complex data really did some complex stuff, we really need tests on that. Otherwise, our tests are relying on something that we can't just easily say is working correctly. And we might have tests that are passing not because they're actually passing, but because we messed up our test fixtures. And that is the worst. Like, I've definitely had bugs that, the test looks good. You go to the setup, you go to the fixtures, and you're like, this doesn't make any sense. It's only passing because we messed up our test setup. So this lets you write test complex data and take in that complex data out and just test things not on your test, but you're testing your fixture, which is pretty cool. So because that complex data is something that is separate and testable, you can test it separately. So you don't have to test two things at once. So instead of implicitly testing it while you're testing your actual code, you say, I want to test to make sure this is good. All right, this is good. Now let's test our actual code, which will save you a lot of headache down the road. And just think of all the complex things you can do in test setup and teardown, whether this is some mocking and database setup. Maybe you're doing API calls if you're writing integration tests. Hopefully you don't have to do very many of those, but if you've ever used something like AWS that's really, really hard to mock, there are trade-offs there. So debugging. So this is where writing tests makes writing good code so much easier. So if you're, let's say you have a Django web app and you're trying to figure out why when you click this button based on the current state for this user, the thing happens, right? So with stateful apps, often testing is, like most of your work in testing is like setting up all the preconditions so you can test this thing, especially if they're destructive. Like if you're doing a post that changes data that then changes what you have to go back and do, that gets really tedious. And if you're like me, you're going to be a little lazy and you're probably going to cut some corners on the test setup and you're not going to click through things and you're going to make changes and not test previous things. And then you have broken things that used to work. So here, if you write your test first, you can then, my thing didn't work. I'm going to jump right into PDB right there reliably and play around with the code. And you can actually fix your code in an interactive session to make sure it works the next time and then just rerun that test. So with nose test, you just -- PDB as soon as your test fails, as soon as it gets an exception or a failure, you're going to get an interactive Python debugger prompt where you can inspect variables, you can change behavior, you can get all the power of the debugger with the context of the exact situation you want to test. No having to go click through things and create a user and, oh man, I need to delete this guy's last join date because this test I really want to write is only for, or last login date is only for users who haven't logged in. So it saves you time. You can also do PDB when you want it. So sometimes you won't have a failure. So like one trick is to just PDB and then throw an assert 0 in your test. But you can also do a set trace. So nose.tools, set trace, Pytest, set trace, call set trace anywhere in your code, anywhere. It doesn't have to be in a test. Could be in your actual application code or your function code. And that drops you right into the debugger. And you get to poke around and see what's working and what's not working, which is a really powerful technique. If you've ever used something like, a Selenium test where a test run takes a long time and you can't just keep changing it, rerunning it, this helps so much. It's like Selenium tests, it might take 10, 15 seconds just to get to the part of the page you actually want to test. And you're like, oh man, I missed this, not a semicolon because it's not JavaScript, but I missed this, I fat fingered this variable name. now I have to wait 15 seconds. And just being able to do, well, I'm just going to do set trace and then live code my test all the way out saves a lot of time. So now I want to talk about plugins. So kind of the Pythonic philosophy is batteries included, and both Pytest and no-boilerplate have some really powerful plugins included, and then they have a really good third-party plugin ecosystem. So almost any of the testing problems you're going to face after you write your first easy tests, someone's got a plugin to solve that thing. You want to test Django? We have a Django, Pytest Django and nose Django and Django nose. We have the pyramid there's everything. There is a Pytest or nose module for that thing. You can also do things like code coverage. So code coverage is, I want to know what I'm not testing by seeing what lines are actually hit. Like if a line is not executed, I want to know that and know that I maybe need to write a test there. And they can integrate with both Pytest and nose. We've got Tox. Tox is, again, really cool. If I have, let's say you have a library that you want to work with, Django 1.5.6, or let's say 1.4, 1.6, 1.7, and like 3 different versions of Celery, because it's relies on Celery. Testing that by hand would be a nightmare. You would basically not test it and let your users test it for you and say, build is broken or broken on Django 1.6 with Celery 2.7. You're like, oh, now I have to go find that, install it. Well, Tox just lets you define things in a file and just write Tox, say Tox, and it'll just go and test all of your things and tell you what's broken. And you put that in continuous integration, which Calvin's going to tell you about, and you feel really good that you're actually, you don't have, because you get that nagging feeling like things are broken, I just don't know what they are, but I don't have the energy to go find them. And that's not a great feeling. Tox lets you, get that warm, fuzzy badge on your GitHub page, the build passing, and like, yes, things are not broken. So parallel test running is something that will happen if you write a lot of tests, which you should. If you have a project you're running, sometimes it's nice to run tests faster over multiple machines. And let's say you want to do continuous integration and you have Jenkins. Well, Jenkins needs XUnit output, this XML format, to give you nice test result formatted things. Well, nose and Pytest have that. So those are some examples. There's a lot more. Pytest has a really cool page where it has the build status of a lot of their plugins. And on one page, it's a Heroku app. If you Google Pytest plugins, it'll come up on the first page. Nose has a lot of built-in plugins with pretty good documentation, and then a lot of third-party plugins. Nose's plugin ecosystem, they have a lot of plugins, but they're not as well organized, I would say, as the Pytest plugins. Like Pytest project infrastructure is a little better. So I talked about Tox, different Python versions, different requirements. It's really great. This is an example of parallel test running. So you can just say, hey, nose, use multiprocess to use 2 of my CPUs to run my tests. And if you've done a good job with test isolation using like your temp directory helpers, that'll just work. Sometimes you'll need to do some tweaking to make things not collide if they're running at the same time. But that can give you around a 2x speed up of your test runs, depending on your tests and whether the IO bound and CPU bound and all that stuff. But that's pretty easy to just type that and it'll go. With Pytest, you have to install Pytest xdist. So pip install pytest-xdist, and then just say, hey, I want 2 processors, -n2. So very similar functionality. You get all the same benefits. So now we've got parallel tests, but what if we have a bunch of, that's on one machine, but what if we have enough tests that we want, it might take a couple hours to run them, even on one machine, we still only get, maybe it's down to an hour. We want to run these across a lot of machines because we want our tests, and Calvin will talk about this, we want our test suite to complete quickly. Some people, I think 10 minutes is kind of what you'll see thrown around the internet. I think it depends on how much effort you can spend into improving your tests and what your process is and how often you deploy and all that stuff. But there's some distributed nodes is one tool that lets you distribute nodes and kind of distribute tests in kind of a shared nothing infrastructure. So the nodes don't have to talk to each other basically, so you don't have to deal with networking stuff. It just uses consistent hashing to say, there are 3 total nodes, you are node number 2, or you are node number 2, just run your tests. And they will all use the same algorithm, and they will just pick their tests. So that's kind of nice if you get a lot of tests. XUnit output, this one's really easy. In Pytest, it's built in, JUnit XML equals path. In those tests, also built in, -- with XUnit, you're going to get XUnit output. You can throw that to Jenkins and make sure your tests keep running and see when they break and all sorts of great stuff. So I'm going to talk a little bit about plugin authoring. I'm going to go quick through this. So plugin authoring, if you need to do something setup-y and teardown-y and powerful-y, Nose and Pytest give you lots of really good hooks. So you can go in and you can get a hook that's pre-test case setup, post, like every step in the process, they'll give you a hook to get into, whether it's test selection, test output. And you can get in and you can write some really powerful things. Like we, in the long ago when there wasn't really a good nose plugin for Django, we wrote something that's basically a plugin system based on Nose's plugin system, so you can write plugins for the Nose plugin for Django. Like there's lots of hooks. It's really powerful. You can go as deep as you want. Yeah, testception, exactly. I need tests for my tests. So you can write a full text engine search setup and tear down. So if you have to write, you have to build a Sphinx index based on data, you can do that. So those are Nose and Pytest. You should write tests. That's a takeaway from this talk. And both the Nose and Pytest documentation are good enough to get you started. Just write test _ the thing, assert some stuff, and start testing now. I'm Policystat. We're hiring, so if you're looking to do Python things and write a lot of tests and have a big test suite and stuff, you should talk to me. It's just Wes at Policystat. So now we've got, how much time? About 9 minutes?
Yeah, 5 minutes for questions.
5 minutes for questions. So does anyone have any Pytest or Nose questions?
I have a question. I always found in Nose, like selecting tests, like a specific test was difficult to run. But you have the long thing where you do the data path and the colon and then
Right.
the test name. It seems like I could never get that to work properly.
So we're talking about like maybe the third middle one?
Yeah, or the last one.
So,
And you mentioned the plugin to do autocomplete.
mm-hmm.
How does that work?
So the plugin, I think there's a Pytest plugin to do this, but there's a Nose test plugin that just does like a abstract syntax tree parse of your Python module and will actually parse out the things so that those don't autocomplete. So I should have put a link up to that actually. I think it's just Nose autocomplete, I think will get you there. So that will help. Yeah, because sometimes if you get the colon in the wrong space, it's not intuitive, and if you have long test paths, you don't want to type all that stuff out. One way to avoid that problem entirely is you can run, you can do -- with IDs whenever you run your tests in Nose, and then the next run you can do failed. So let's say you would just want to rerun the failed test, which is kind of a pretty common pattern. You can just give a failed argument and it'll run the test that failed last time. So if you're just iterating on some tests, that can kind of give you a workaround. But yeah, typing the full pass to test is often annoying. And you'll get complete on the path, but then you still have to be like colon test function. So I agree that's not ideal, but it's much better than doc test land where you're just like, I guess run all the tests in this file. Hopefully it will get the one I want.